Hi students, in this lecture we are going to continue Coulombs law. So in the last class we have seen what is a Coulombs law. It's a statement, right? And next the value of K epsilon naught. If that change in a medium, then it is in the place of epsilon, writing epsilon, sorry, in the place of epsilon naught, writing epsilon which is equal to epsilon naught and epsilon naught, right? Let us now continue. It is a principle of superposition. So what it means, suppose there are number of charges. Let us consider Q1, Q2, Q3, Q4. Like this having many charges. Let us say we are focusing force acting on one charge, that is Q. Force acting on one charge, that is Q. So here what we are doing is we calculate force on this charge. Force on this charge by each charge individually. That means because of Q1 on Q, what is the force? Let us call it as F1. Because of Q2 force on Q, let us call it as F2 bar. That means when there are no other charges, force by Q1 on Q. Next, force by Q2 on Q when there are no other charges, only by Q. In the same way, by Q3, force on Q alone, it is F3 bar. Now, net force acting on Q is given by vector sum of all these forces. That is F1 bar plus F2 bar and so on. So this is what we call principle of superposition. So whenever calculating net force acting on a charge, what we can do is calculating force due to each charge individually, then taking the vector sum of all those forces. And that is known as principle of superposition. We can see here statement. Force of a charge, sorry, it's actually force on a charge by a number of charges is the vector sum of the forces acting on it by all other charges individually. That means when we focus by Q1, we assume there are no other charges, only force by Q1 on Q. Same way only by Q2 on Q. Then take the vectors. Okay. Right. Now let us solve few problems based on Coulomb's law. Right. See first problem. Find the electrostatic force. Find the electrostatic force by a charge 2 Coulomb on another charge minus 3 Coulomb, whose position vectors are given by I cap plus 2j cap plus 3k cap and 3I cap plus 6j cap plus 5k cap respectively. So we are given 2-point charges and their position vectors are given and asking by 2 Coulomb charge on minus 3 Coulomb charge. See how we are solving it. First write down the given data. So 2 Coulomb. Right. It is now 2 Coulomb. Let us take it as a Q1, that is 2 Coulomb. Q2, that is minus 3 Coulomb. Given their position vectors, R1 bar. R1 bar is given as, it is I cap plus 2j cap plus 3k cap. R2 bar 3i cap plus 6j cap plus 5k cap. So first what we are doing is a force acting on Q2 by Q1. So we want position vector of Q2 with respect to Q1. That is, I am writing here R bar equal to position vector of Q2 with respect to Q1. So R bar equal to, directly I am writing R2 bar minus R1 bar. See this value how much? 3 minus 1, 2i cap, 6 minus 2, that is 4j cap, 5 minus 3, that is 2k cap. So we got position vector. And if you consider modulus value, then we are going to get R, right? Distance between them. Okay. Now force in vector form is given by F bar, force on Q2 by Q1. It is 1 by 4 pi epsilon naught, value I am writing here, 9 10 power 9. It is 1 by 4 pi epsilon naught into Q1 Q2. Q1 2 Coulomb, Q2 minus 3 Coulomb. So writing including sign, okay, by R cube, by R. Here you can see the value of R, square root of 2 square 4, 4 square 16, 2 square 4. It is now root 24. Okay. So it is 1 by 4 pi epsilon naught Q1 Q2 by R cube into R bar. R bar is now, R bar is, okay, that I'm writing here R bar, you can substitute value. Now here what we have to understand is, this is a 2 and this is a minus 3. So this value is negative. Means the force is opposite to R bar. That means if you see here Q1 and this is a Q2. Now this is R bar. This is R bar. Coming to direction of force. Direction of force. That is opposite to R bar. So force is now like this. Okay, F bar. That's why we are right here including sign. Okay. Its meaning is Q1 is attracting Q2. Attracting. That's why pulling, right? Attracting means. Suppose both have same sign, then F bar will be along R bar. Then we have draw arrow like this. Means repelling. Okay. That's why when we take vector form, we should write magnitudes. Sorry, we have to write charges along with the signs. Okay. So I hope you got clarity. And in the place of R bar, you can write this one. In the place of R, it is root 24. Okay. Right. Now see next problem. Two equally charged spheres of same mass are suspended from same point by threads of same length or in equilibrium. When the entire system is immersed in a liquid of density 10 gram per cc and its permittivity is 6. So we have discussed that its permittivity means it is dielectric constant, right? It's actually relative permittivity. Okay, relative permittivity is 6, means dielectric constant. The divergence angle between the threads does not change. Condition is the divergence angle between the threads does not change. So here permittivity in the sense actually is relative permittivity. Okay, we have to make correction here, which is known as dielectric constant. Now we have to calculate density of the material of the sphere. So condition is equally charged, suspending from same point by threads of same length or in equilibrium. Okay. So density of liquid 10 gram per cc, dielectric constant is 6. So we have to find density of the material of sphere. See how we are solving. Right. So first let us draw diagram for the given data. So first I'm drawing here from a ceiling with the help of two threads. These are now two threads. Let us take charges at Q each. Suppose the angle is a theta, then this also theta. Okay, by symmetry. Each of same length given, right? If you focus one charge, force is acting on that. This is now repelling this one, right? I'm taking a different color to make it clear. Repulsion, that is now like this. I'm taking as F, that is a K into Q1, Q2 by square of the separation between them. Okay. Next, we can take gravitational force. That is gravitational force mg downwards. This is not visible, right? Let us change the color. Gravitational force, which is downwards. And tension is now along the spring length, that is T. So what we can write here? If you focus along vertical, T cos theta balancing mg and horizontally T sin theta. So T sin theta is balancing mg. T cos theta balancing repulsive force. That is repulsive force. So from these two, what we can write? From those two, we can write. From those two, we can write F equal to mg into tan theta, right? Or if you remember Lami's theorem, which we have learned in vectors, then directly we can write F equal to mg tan theta. Okay. Now in the first case, what is given? It is an air medium, right? Now they are placing liquid of density of liquid given 10 gram per cc, and we are given dielectric constant, that is relative permittivity, that is a 6. Okay. You can see now initially in air medium, now placing in liquid. Condition given that divergence angle. Here divergence angle means 2 theta. So this angle is not changing. Okay. That means this angle, this is a tan theta remains the same. So what changes is now force. If initially air medium force is F, now force becomes F by 6. Right? I am writing here. Or let us take in liquid medium, force is F dash. F dash equal to, in the place of mg, it is mg into 1 minus rho L by rho B. Right? Because we have to focus weight minus buoyancy force. Okay? Into tan theta. Right? Let us take now ratio. Ratio, when we take ratio F by F dash, then what we are going to get? In the place of F dash, we can write it is F by that relative permitted. It becomes F by 6, right? Because F dash is 1 by 4 pi epsilon. In the place of epsilon, epsilon naught, epsilon r. Okay, right. Now take ratio, then see what we are going to get. I am saying this is equation 1 and this is equation 2. Now taking ratio, it is 1 by 2. So F by 6, it becomes a 6. 6 equal to mg gets cancelled. It is now 1 by 1 minus rho L by rho B. Rho L, that is given as 10. So 10 by density of body. That implies, see what we get. 1 minus 10 by density of body is equal to 1 by 6. Right? That means 10 by density of body is equal to 1 minus 1 by 6. That is 5 by 6. Right? So 10 here, 5, 10 in 2 times. That implies density of body, density of density of body is equal to, see, 5, 2 times 2, 6, 10, right? It is 12 gram per cc. Like this, we can calculate density of liquid, sorry, density of body. Okay. So here key point is angle of divergence is not changed. Okay. Directly can use here Lami's theorem to get this condition F equal to mg tan theta without writing these two equations. Right. I hope you got the clarity. Let us go for next problem. This is a previous IIT problem, 1987, given for 2 marks. Let us read the question once. A charged small q is placed at the center of the line joining two equal charges q, capital Q. The system of the three charges will be in equilibrium. The system of three charges will be in equilibrium if q is equal to, okay. So important condition is system of the three charges will be in equilibrium. Its meaning is on each charge, net force must be equal to 0. The meaning of system of the three charges will be in equilibrium. If on each charge net force 0, then we say system is in equilibrium, right? So we have to find small q, where we are placing at the center of the line joining those two charges, right? See how we are starting this problem. Right. So we are given two charges, capital Q each. At the midpoint, I'm taking a different color to make it more visible. At the midpoint, keeping a charge Q, small q, condition is system must be in equilibrium. If you observe carefully, this charge repels this charge. That means on this charge, by this charge, force is right side. So to make net force 0 on this one, this charge has to attract this one. So it must be right side. Same logic on this charge by this one left side. Therefore, by this, it must be right side. And anyhow, at midpoint means these two charges will attract or will repel with the same magnitude. So anyhow here, net force will be zero. That is clear. So now I am focusing, let us say this charge. On this charge by capital Q. See force how much? I am writing 1 by 4 pi epsilon naught as a k into Q1, Q2, Q square by separation is a D, so D square. This force must be balanced by force by this charge on this, and that is now left side, right? Because to balance, it is a K into Q into capital Q by midpoint means separation is D by 2. So D square by 4. So D square gets cancelled. Right? So D square cancels. K cancels. Q square 1 Q. From this, small q is equal to capital Q by 4. So we got magnitude of charge, not sign. And here you can see this charge has to exert a force on this left side. Its meaning is it is attraction, right? It is attraction. That means if a Q is a positive, this must be negative. Therefore, here we have to take negative sign. So I am taking a different color here. So this is only magnitude. If you want to sign, then sign will be minus, okay, minus Q by 4. If Q positive, this is negative. If Q negative, this will be positive. So key point is on each and every charge, net force must be 0. Okay, right.